This is SpaceTime, Series 29, Episode 85, for broadcast on the 17th of July 2026. Coming up on SpaceTime, detecting nuclear weapons in space, NASA's rescue mission to save the Swift Space Telescope reaches orbit, and stopping astronauts from wanting to kill each other on long space trips. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New modelling shows that small CubeSat-sized spacecraft not much bigger than a fridge could be used to detect the presence of nuclear weapons on satellites in orbit. A report in the journal Nature claims the spacecraft could be used to verify that nations are complying with the Outer Space Treaty, which prohibits the placement of nuclear weapons in space. There's currently no way to verify spacecraft don't contain nuclear weapons. In 2024, US government officials warned that Russia could be developing a new satellite designed to carry nuclear weapons into space. The claim followed the launch of a suspicious Russian spacecraft, the Cosmos 2553, into low Earth orbit in 2022, just weeks before the country's invasion of Ukraine. Moscow claims the suspicious satellite is used for surveillance and sensing. However, US authorities believe it may be carrying components of a nuclear device undergoing testing, with a possible future goal of fielding an actual nuclear anti-satellite weapon. The detonation of a nuclear weapon in orbit could destroy many satellites, not just military and reconnaissance satellites, but also communications, navigation, and scientific platforms. The thing is, the Kremlin launched Cosmos 2553 into a really strange and unusual orbit, one that goes through hostile radioactive environments normally avoided by most spacecraft. The authors of the study warned that the spacecraft's unusual orbit could be because it's highly radioactive, and that's the best orbit for trapping electrons if you want to detonate a thermonuclear weapon in space. The authors say their simulations suggest that a 9-unit CubeSat could identify a thermonuclear weapon at a distance of about 4 kilometers. The system would involve an inspector spacecraft maneuvering next to a suspected satellite and then detecting neutrons generated by high-energy protons colliding with radioactive material. The sensor system would detect a nuclear weapon with 99% accuracy if it was orbiting within 400 meters of the suspected satellite for about a week. That detection time could be cut to a matter of hours if multiple sensors were used, or the sensor satellite was able to get to within 1,000 meters of the suspected spacecraft. While normal satellites would emit many neutrons, there are still naturally occurring protons, neutrons and electrons in the atmosphere, especially in low Earth orbit. The new design uses 2 panels made up of pixels of neutron sensors known as scintillators that interact with radiation and emit light. Panels are sandwiched between synthetic crystal diamond detectors that allow the system to distinguish between neutrons coming from radioactive materials and natural protons, neutrons and electrons. The 2-panel construction could then be used to estimate the direction of the neutron, allowing it to differentiate between natural atmospheric neutrons and those coming from suspected satellites. Back in 1962, the United States detonated a 1.4 megaton thermonuclear warhead in space, which unintentionally destroyed multiple satellites. The blast released enormous volumes of highly energized electrons, and many became trapped in Earth's magnetic field, where they damaged any electronics on the spacecraft in their path. The authors point out that when you have a nuclear detonation in space, the whole body of the bomb becomes ionized, and nearly every single electron in the weapon's mass becomes free. It gets injected into the inner Van Allen radiation belt, and once there, the electrons start hitting everything flying through those belts, causing ionization and radiation damage. And as you go further out into space, you create these thick belts around the Earth populated by highly energetic protons and electrons, indiscriminate satellite killers. This is SpaceTime. Still to come, NASA's rescue mission to save the Swift Space Telescope, and stopping astronauts from wanting to kill each other on long-duration space flights. All that and more still to come on SpaceTime. NASA's Swift Reboot Rescue mission is finally on its way to intercept the Gamma Ray Space Telescope and try and save it from a fiery fate. After 2 scrubbed launch attempts, Catalyst's Link spacecraft is now in orbit and closing in on the 22-year-old Swift Space Telescope. Launched in 2004, SWIFT is an early warning system searching the skies for gamma-ray bursts, which are the most powerful explosions in the universe since the Big Bang, but which often only last for a few seconds at most. SWIFT scans the heavens in visible, ultraviolet, X-ray and gamma-ray light, telling astronomers a gamma-ray burst just happened and where it's located, thereby allowing scientists to turn their telescopes towards the event and study it and its afterglow in more detail. The problem is Swift's orbit's been decaying due to recent space weather events, which have caused the Earth's upper atmosphere to expand, resulting in increased atmospheric drag impacting the spacecraft. Swift was expected to remain in orbit for around 30 years, and so wasn't equipped with thrusters, thereby making it incapable of boosting its own orbit. But the especially active solar activity of recent years has intensified drag on the spacecraft, bringing it down much faster than expected. It's now orbiting at around 300 kilometers in altitude and only has a few months of life left. Rather than allow Swift to fall back to Earth and burn up during atmospheric re-entry, NASA's decided to try a rescue mission. Arizona company Catalyst were given the opportunity to quickly design and build a spacecraft, which they called Link, which could rendezvous with Swift in orbit. Because Swift doesn't have any docking hardware, Catalyst developed a custom capture mechanism which will use 3 LiDAR-guided robotic arms to latch onto a structural feature of the Swift spacecraft without damaging the telescope's delicate instruments. Link was carried into orbit aboard a Northrop Grumman Pegasus XL rocket, which was drop-launched at an altitude of roughly 40,000 feet or 12,200 meters from the underbelly of the Stargazer, a modified L-1011 airliner flying above the Marshall Islands. The launch was scrubbed twice, first by bad weather, then a software glitch in Pegasus' navigation system. Luckily, it was a case of the third time's a charm. Once it reaches Swift, Link will maneuver around the spacecraft like a spy inspection satellite, checking for any damage and then targeting the best latch points to grab onto. The capture itself will be especially tricky. That's because Swift was never designed to be touched once it reaches orbit. Mission managers determined that a series of small metal rings used during ground handling operations before Swift's launch may be the best possible targets. But it's still all really iffy. You see, no spacecraft has ever attempted to use these flanges as grappling points before. While Swift can't boost itself into orbit, it can control its own orientation and should be able to assist Link in proximity maneuvers by maintaining the appropriate orientation. Once the 2 spacecraft have docked, Link will fire up its own thrusters, gradually raising Swift back to its original 600-kilometer high orbit over a period of several months. If it all works, Swift will resume its mission searching the skies for the next gamma-ray burst. This is SpaceTime. Still to come, stopping astronauts from wanting to kill each other on long-duration space flights, and later in the Science Report, good news for chocolate lovers with the discovery of 4 new species of cacao plant. All that and more still to come on SpaceTime. When you think about it, it's tough enough getting on with family members at home or with people you have to work with. But imagine what it must be like if you're stuck in a confined place with a small group of people on a multi-year mission to Mars. And just such a journey could be less than a decade away. It takes 6 to 7 months to get to Mars, another 6 or 7 months to return to Earth, and then there's the amount of time you'll need to spend on the red planet. Because the Earth and Mars travel around the Sun at different speeds, the optimal launch windows for a fuel-efficient round trip only open every 26 months. And that leaves mission managers with 2 choices. Either you stay for just a few days, which seems hardly worth the effort for such a long trip, or more likely, you undertake an extended stay on Mars for more than a year before the planets realign. That's a long time to be stuck in a confined space with a bunch of strangers and their little habits and idiosyncrasies, let's call them quirks, with nowhere for you to escape to get away from it all. Like it or not, you're going to be stuck with these people day after day, month after month, year after year. And no matter how good your training, there's going to be pressure. Making matters worse, there's the issue of communications delay between the Earth and Mars. Now, depending on the orbital positions of the two planets, the one-way delay in communications between the Earth and Mars will range from 3 minutes at their closest approach to around 22 minutes when the planets are on opposite sides of the Sun. And then there's the issue of things going wrong, stuff breaking, the unexpected. If something goes wrong on the International Space Station, there's a leak or the toilets don't flush, well, Earth's only 400 kilometres away, and communications is almost instantaneous. But that sort of safety window doesn't exist on a trip to Mars. And so there are all sorts of real problems NASA's trying to address through a range of simulations, both through exercises aboard the space station and in mock-ups on the ground, to try and overcome these problems, work out solutions before the problems become real. Now, one of those is a joint study by NASA and Michigan State University called Project Fusion. Fusion standing for Facilitating United Systems of Interdependent Organizational Networks. It's focusing on teamwork under pressure. Dorothy Carter from Michigan State is one of the scientists involved in the project. She's analysing how to understand and mitigate communications delays between mission control on Earth and a crew of astronauts on a mission to Mars. Carter and colleagues at Michigan State's Kessler Lab have been working with volunteers living and working inside NASA's Human Exploration Space Analog, or HERA, a mock-up habitat set up in a hangar at the Johnson Space Center in Houston. They're practicing real-time simulations to see how people interact in different pressure situations under different stress conditions, with a range of variables including communications delays. Carter's research, reported in the journal Personal Psychology, found communications delays disrupt collective attention dramatically, affecting crew performance. They found that interventions that target someone's experience level with a task or capacity, address message simplicity, in other words clarity, and create a sense of shared leadership among team members, connectivity, can all help preserve collective attention in situations with delayed communications.
The Brian and Michelle Kessler Lab is an amazing experimental laboratory, the physical space that allows us to conduct high-quality, basic science research on teamwork. We've had this kind of amazing opportunity to collect human subjects' experimental data, both here in the Kessler Lab, as well as in partnership with the Human Exploration Research Analog, which is a capsule that's located inside of a hangar at Johnson Space Center in Houston, Texas. NASA has this grand goal of sending a team of humans to deep space destinations like the moon and Mars and maybe beyond. And it really requires this large collaborative system, or a multi-team system, to work together and coordinate and collaborate to achieve this goal. Participants who were living and working inside of the HERA capsule, they teamed up multiple times with undergraduate students here at MSU who were located here in the Kessler Lab to participate in our research study. One of the things that we find is that they really need what we call collective attention, which means that multiple people from different disciplines are co-focusing their attention on the same problem space at the same time. It's just harder to get on the same page with somebody when you can't talk to them in real time. Things like training and simplifying communications, clear and concise messages, developing trust and shared leadership help support collective attention, even during delayed communication. We need people to work together collaboratively across disciplines, and we need leaders to guide us in those pursuits.
That's Professor Dorothy Carter from Michigan State University. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study indicates that people who can speak more than one language seem to have younger brains. The findings, presented at the 2026 Federation of European Neuroscience Societies Forum, followed a detailed analysis of 700 people from the Basque region in Spain who spoke between 1 and 4 different languages, including combinations of Spanish, Basque, French and English. The authors measured brain activity to create a brain aging clock, then used this clock to gauge the brain's age of 144 other people. When comparing people's real age with the age of their brain, they found that those who spoke 2 languages had brains that appear to be 6 years younger than those who only spoke 1 language. And for those who could speak 4 languages, their brains appear to be 13 years younger. A new report warns that 2/3 of Australian adults and a quarter of Australian kids are now considered overweight or obese. The findings by the Australian Institute of Health and Welfare are based on data from 2023 and 24 and explain why almost $11 billion was being spent on treating overweight and obesity last year. The authors say that compared with a decade ago, almost an additional 10 middle-aged adults in every 100 and an additional 9 in every 100 young adults were living with abdominal obesity, which is measured by waist circumference. A new study has found that almost half of all fatal electric scooter accidents in Sweden are caused by the rider being under the influence of alcohol. The findings, reported in the journal Safety Research, show that these fatal crashes mainly occurred in the evenings or through the night, and in all cases, no helmet was being worn by the victim. The authors analysed all fatal crashes involving electric scooters, electric bicycles and conventional bicycles in Sweden between 2016 and 2024. Alcohol is often a factor in fatal crashes occurring with all three of these vehicle types, but the figures for the electric scooters stood out. Of the fatal e-scooter crashes, 44% of riders were under the influence of alcohol, compared to 27% among e-bike riders and 13% among cyclists. Blood alcohol levels were high across all three groups, with e-scooter riders averaging 1.8. That's more than 3 times the Australian limit of 0.05. Scientists trudging through Peruvian cocoa forests have discovered 4 new genetically distinct species of cocoa, the tree responsible for one of the world's favourite things, chocolate. Many Peruvian cocoa farms rely on wild and semi-wild cocoa varieties, which have often not been altered by selective breeding or genetic engineering. A report in the journal PLOS ONE analysed the genetic diversity of 390 of these farm cocoa plants and found 4 previously unidentified genetic groups. These have 1-letter differences in their code of DNA compared to the varieties that were already known. The authors say 2 of the 4 new groups have genetic ancestors that suggest they might produce especially high quality and delicious beans for chocolate making. A famous psychic has failed to foresee the disappearance of her own pet peacock. The skeptic's Tim Mendham says not only did she fail to see the future of her beloved bird, but her fellow psychics also failed to predict where the feathered friend might be.
Well, there are major issues in the world today, right? This became a story fairly recently that a lady who is a psychic, a professional psychic herself, whose pet peacock named Kevin disappeared one day. So she was looking for it and couldn't find it. And even using her own psychic ability, she couldn't find it. So she called up her friends, who are also psychics. Apparently this is a circle that she lives in. And they were suggesting all sorts of different things to try and find a peacock. Her husband was very accommodating. I don't think he's psychic, but never mind. The next day they went out with their dog and the dog found the peacock. Now the dog ran straight to the peacock.
It says a lot about psychic abilities, doesn't it?
It says a lot about dogs too, actually. But apparently it was near a place where a psychic has suggested it to be near water. It's a very strange little story. But I mean, psychic found my missing peacock is not actually correct. The dog found it. And there's no indication that the dog is psychic at all. Dog's name, by the way, was Lincoln. So Lincoln found Kevin. It's a heartwarming story.
That's the skeptic's Tim Mendham, and this is Space Time. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.